Hello, today I'm going to teach you how to write net ionic equations. So in this particular scenario, we're going to be dealing with double replacement reactions, right? And the goal of net ionic equation is to see which ions actually participate in creating our product. And there are some rules that we're going to follow whenever we're trying to predict a double replacement reaction. So just to review, a double replacement reaction occurs when you have, let's say, an ionic compound that combines with another ionic compound. And basically what happens is they switch partners. So in the case, A is going to combine with D, and then B is going to combine with C, okay? And as you can see, the way that they exchange partners, so to speak, is you have to, just like in single replacement, the element of the same kind is going to basically switch partners, right? So you always want to have a negative anion with a positive anion. Okay, so how do we actually do that? Well, here's an example. So in this net ionic equation, so first you have an equation. So here we happen to have sodium carbonate, aqueous. And of course, the state of the compound is very important in net ionic equations, because I'm going to show you in a moment that only the spectator ions actually do not participate in the equation. So here we have 2AgNO3, that's silver nitrate, also aqueous, combine to get silver carbonate, which is actually in a, let me correct that. Yes, silver carbonate. So Ag2CO3 in a solid state that combines with sodium nitrate in an aqueous state. So why are these states very important? Well, it turns out that only the aqueous compounds will break apart into their respective ions. What do I mean by that? Here is what I mean. So if you look at this particular compound, it will break it apart into its respective ions. So here you would have 2 sodium ions. Okay, and they're of course coming from aqueous. It will break in part into 1 carbonate ion. And so then you continue this with this particular compound because it is aqueous. And what you will see here is that you have 2 Ag silver. Now remember, there's a big 2, there's a coefficient, so that means you would have also 2 nitrate ions. As they come together, what you will see is that because AgCO3, silver carbonate, is a solid, therefore it has to stay together. You cannot break it apart. So this one will stay AgCO3S. It will stay together. The next one, because it is aqueous, will have to break apart. Okay, so what are the 2 main ions involved here? You're right, it will be sodium and nitrate. Now remember, there's that coefficient over here, so we have to have 2 sodium ions, aqueous, plus 2 nitrate, NO3 minus aqueous. Very good. The next step is very simple. What we need to do is identify the ions that appear on both sides of the equations. They're called spectator ions because they do not actually participate in the overall equation. Okay, so we have this right here. This is called a total or complete net ionic equation. Sorry about that. This is called a total ionic equation right here. So to get the net ionic equations, we're going to eliminate those that appear on both sides, right? And as you can see, we see Na here, so we're going to eliminate that one, and then Na here. We also see 2 NO3s here, and then 2 NO3, okay? And notice that they're all aqueous, right? I should probably write that down because that's going to be important. So we are left with, at the end, only these that are not spectator ions. And so now these become involved in my net ionic equation. So here I have 2 Ag plus aqueous plus 1 carbonate ion aqueous gives me Ag2CO3, and that's solid. And that, my friend, is my net ionic equation. Let's do another one just to make sure we understand the process. So here, for example, we have iron nitrate. That's a 3 over here that we combine with, and it, of course, remember we need to put the states, so we can't rush too fast. And then we're going to combine with sodium sulfide. So we have sodium sulfide aqueous. That will give us iron sulfate, which is a solid, which will give us plus 2 NaNO3 aqueous. Now, it's very crucial that before you begin, your chemical equation is balanced. Normally, it's given to you, but you may have to balance it on your own. We'll do probably that one the next time. So, can you identify the compounds that need to be broken up? Absolutely. We're going to have this one, and this one, because they are in aqueous form, right? So we have the AQ over here, AQ, that tells us that they can be broken up. So let's do that. So we have iron 2 plus aqueous plus 2 NO3 minus, that's aqueous also, plus 2 nitrates, that's aqueous, plus S2 minus, which is aqueous. Very good. On the other side, we have FeS solid, which stays together. And then we have 2 Na sodium ions that are aqueous in solution. And then 1, or should I say 2 NO3 minus aqueous. Okay. So that's my total. Again, this is my total ionic equation. This shows me in solution which ions are actually going to break up or break apart and which will stay together. So now to get my net ionic equations, remember, I'm just going to eliminate my spectator ions, right? A spectator is in the audience, watches. These are ions that just watch and don't really participate in the formation of the solid product. So we can see that the 2 Na plus right here are the same, right here. And we can see also that we have 2 NO3s that do not participate. So we're going to be left with this, and this as our total net ionic equation. So when we put it together, we get iron 2 plus aqueous plus S2 minus aqueous give us FeS solid. And that is, again, my net ionic equation. Do you see how this net ionic equation is already balanced? Wonderful. Time to go to our last and final example. So here we have 2KF aqueous that combines with magnesium nitrate, also aqueous, and it gives us potassium nitrate, aqueous also. Aqueous just means it dissolves in solution, right? It's soluble. Versus magnesium fluoride, which is solid. S is not for soluble here, it's for solid. It means it's insoluble, right? It doesn't break apart in solution. So, you know what to do. Let's figure out the ones that need to be broken up. That's right. Those three are aqueous, so we're going to break them up apart. So we have here we're going to have 2 potassium ions, aqueous, plus 2 fluorine ions. Then we're going to have magnesium 2 plus aqueous, and we're going to have 2 NO3 minus aqueous. This is going to stay together, and then this is going to break apart. So now we have 2 potassium aqueous plus NO3 minus aqueous. And then we have a MgS2, which is going to remain solid. So here is our total equation, right? Total ionic equation. And now go ahead and tell me what cancels out. Great. So we can see that the K's, the potassium, are going to go, as well as the NO3. So now we are left with the F's and the Mg's and the product. Okay? So let's put this together. So now we have 2F plus aqueous gives us Mg2 plus aqueous. And then we are left with MgF2 solid. And that, my friend, is my net ionic equation. Now, I made a deliberate mistake in this last one. My question to you is, can you identify where the error is? Pause the video and see if you can figure it out. That's right. Good job. You saw that actually right here, because I have a 2, it should have been actually 2 NO3 minus, right? Because the 2 not only applies to the potassium, but also to the NO3. Good job.